Hello, my name is Ping Ping.
Hello, my name is Earn.
Hello, my name is Sai Mai.
Hello, my name is Poi. Today we will talk about diode.
A diode is a semiconductor electric device that can be found in everyday life such as LED, amplifier, switch, rectifier, or transistor. The diode has two leads, P-type and N-type, are designed to direct the flow charge, allow the electric current to flow the same directions, and prevent current reversing original directions. It's very useful in electronic circuits such as AC converter or prevent switching on the electronic circuit.
N-type is pentavalent impurity such as phosphorus, acetic, antimony, bismuth have 5 valent electrons, and P-type is tetravalent impurities such as boron, aluminum, indium, and gallium have 3 valent electrons. In large current on P side is called anode, and outgoing current on N side is called cathode.
Diodes have many types, and these are examples of diodes. First, light-emitting diodes, or LED, are among the most widely used of all the different types of semiconductor diodes available today and are commonly used in TV and color displays. Second, laser diode is a semiconductor device similar to a light-emitting diode, in which a diode pumped directly with electrical current can create blazing conditions at the diode's junction. Laser is an abbreviation for light amplification by stimulated emission of radiation. Stimulated emission is the basis of working of a laser diode. Next, signal diode is a small nonlinear semiconductor device generally used in electronic circuits where small currents or high frequency are involved, such as in radio, television, and digital logic circuits. Last of our example, the Zener diode. Zener diode behaves just like a normal general-purpose diode consisting of a silicon p-n junction, and when biased in the forward direction, that is anode positive with respect to its cathode, it behaves just like a normal signal diode passing the rated current.
When the anode and cathode of a p-n junctions diodes are connected to internal voltage such that the potential at anode is higher than potential at cathode, the anode is said to be forward biased. Bias is such element made in p-n junctions device so that the device allows to flow of down current in the one direction. The device is said to be forward biased if the anode is connected to the positive end and cathode is connected to the negative end of the battery. The forward bias reduces the potential barrier of diode. It is easy path for the flow of current. In a forward bias diode, current is allowed to flow through the device. Reverse bias, the potential difference increases the strength of barrier, which prevents the charge carrier to move across the junctions. The reverse bias provides to hide the resistive part of the flow to current and hence no current flow along the circuit. When potential at anode is smaller than the potential at cathode, the diode is said to be reverse biased. In a reverse bias diode, current is blocked.
Water of analogy of diodes. When water pressure on left overcomes the restoring force of spring, the gate is open and water is allowed to flow. When water pressure is from right to left, the gate is pressed again. The solid stops and no water is allowed to flow. Spring restoring force is analogous to 0.6 volt need to forward bias a silicon diode. How diode works. When a diode is connected to a battery as shown, electrons from the N side and holes from the P side are forced toward the center by the electrical field supplies the battery. The electrons and holes combine catching the current to pass through the diode. When a diode is arranged in this way, it is said to be forward biased. A diode's one-way gate feature does not work all the time. Typically for silicon diodes, an applied voltage of 0.6 volt or greater is needed always. The diode will not conduct. This feature is useful in forming a voltage-sensitive switch. 1 to 5 characteristics for silicon and germanium diode is shown below. How diode doesn't work. When a diode is connected to a battery as shown, holes in the N side and forced to the left while electrons in P side are forced to the right. The result is an empty zone around the PN junction that is free to charge carry creating a division region. The division region acts as an insulator preventing currents from flowing through the diode. When a diode is arranged in this way, it is said to be reverse biased. Diode application half-wave rectifier. A half-wave rectifier is defined as a type of rectifier that only allows one-half circle of an AC voltage waveform to pass, blocking the other half circle. Half-wave rectifiers are used to convert AC voltage to DC voltage and only require a single diode to construct. Diode convert AC input voltage to a plus DC output voltage. Whenever the AC input becomes negative at diode's anode, 2. The diode blocks current flow. Diode introduce a 0.6 volt drop, so OP peak is 0.6 volt smaller than the IP peak. The OP frequency is same as the IP frequency. The picture shows that diode converts AC input voltage to a plus DC output voltage, so we can see that rectified output waveform no negative half circle.
Diode applications. Full wave rectifier. A full wave rectifier is a circuit arrangement which makes use of both half cycles of input alternating current AC and converts them to direct current DC. In our tutorial on half-wave rectifiers, we have seen that a half-wave rectifier makes use of only one half cycle of the input alternating current. Thus, a full-wave rectifier is much more efficient, double plus than a half-wave rectifier. This process of converting both half cycles of the input supply alternating current to direct current DC is termed full-wave rectification. Full-wave rectifier can be constructed in two ways. The first method makes use of a center-tapped transformer and two diodes. This arrangement is known as center-tapped full-wave rectifier. From the picture, we can see that a full-wave rectifier doesn't block negative swings in the IP voltage. Rather, it transforms them into positive swing at the OP. To gain an understanding of device operation, follow current flow through pairs of diodes in the bridge circuit. OP voltage peak is 1.2 volt below the IP voltage peak. The OP frequency is twice the IP frequency.
What is power supply? A power supply is an electrical device that converts the electric current and come in from a power source. Add the power main to the voltage and current value necessary for powering a load. such as a motor and electronic device. The objective of a power supply is to power the load with the proper voltage and current. The current must be supplied in a controlled manner and with an accurate voltage to a wide range of load. Sometimes, simultaneously or without letting change in the input voltage or in other connect device affect the output. A power supply can be external, often seen in devices such as laptop and phone changer, or internal, such as in larger devices such as desktop computer. A power supply can either be regulated or unregulated. In a regulated power supply, the change in the input voltage do not affect the output. On the other hand, in an unregulated power supply, the output depends on any change in the input. The one thing all power supply have in common is that they take electric power from the source at the input, transform it in some way, and deliver it to the load at the output. The power at the input and output can be either AC or DC. DC occurs when the current flows in the one constant direction. It usually comes from battery, solar cell, or from AC-DC convert. DC is the preferred type of power for electronic device. AC occurs when the electric current periodically inverts its direction. AC is the method used to deliver electricity through power transmission line to home and business. Therefore, if AC is a type of power delivered to your house and DC is the type of power you need to charge your phone, you are going to need an AC-DC power supply in order to convert the AC voltage coming in from the power grid to the DC voltage need to charge your mobile phone battery. The picture shows that circuit in power supply, which include that an AC to DC power supply is built using a transformer and a full wave rectifier. Transformer is used to step down the voltage IP. Rectifier converts AC to pulse DC. A filter capacitor is used to smooth out the pulse. Capacitor must be large enough to store sufficient charge so as to provide a steady current supply to the load. F is rectified signal frequency 120 Hz.